Welcome to Spring LIB.
31.64, we have a contraption known as an autotransformer. You can sort of see why it's called that, because it only has one coil of wire around an iron core, and then there are just what are called taps attached to different points on the single wire to provide the terminals that behave like you'd expect a transformer to behave. So we want to find the various ratios available with this particular one from for a step up and step down configurations. You can use any two terminals as the primary and then any other two terminals as the secondary. One of them is going to be used twice, which is why these are not often used for things like power supplies, because they don't provide isolation between the line voltage and the equipment you're powering with them. So the smallest value we get is if we use the windings between T2 and T3 as the primary, and then all of the windings between T1 and T3 as the secondary. So we can write this as V1(3) over V2(3). So this is the 800 between 2 and 3 plus the 200 between 1 and 2, because we're going all the way from 1 to 3, divided by 800. So this is 1.25. The next largest, or second smallest, uses T1(2) as the primary, and T2(3) so the taps 2 and 3 as the secondary, and taps 1 and 3 as the primary. That's probably the easiest way to write this down. So this is 800 over 200. So this is 4. Now the largest step-up value we can get is if we use 1 and 3 as the secondary, and 1 and 2 as the primary. So this would be the 1,000 turns between 1 and 3 divided by the 200 turns between 1 and 2. So that gives us 5. Now for the step down values, we just invert each one of these, use the primary from this one, say, as the secondary instead, and use the secondary as the primary. So we just invert these numbers and then put them in the correct order. So the largest step-up ratio is going to be the smallest step-down ratio. So that's going to be 0.2. Because inverting numbers reverses their order. The second largest, the next largest ratio is going to be the inverse of this one. So it's going to be 0.25. And then the largest is going to be the inverse of 1.25, which is 0.8.